Hello everyone, welcome to chemistry class. This is the last part for this chapter 4. We are here with the exercise part. Although already you have been provided the exercises in the live classes, this is just for reference in case you need any of the answer. You can just have a look in this video. Also we will see some of the remaining part, only a small part was remaining in the explanation that will complete. Also there has been a confusion regarding the syllabus. It is exactly written correct in the syllabus that is printed and provided to you. That is chapter 1 and 4 only are in the half yearly syllabus. Some students have been asking to me also regarding chapter 2 and 3. See, it has been already reduced by the board side, and those who are regularly following my videos, I had already told you around 2 months back. I had informed that chapter 2 and 3 have been cut in the syllabus. Suddenly it was done, although we were teaching that chapter also, but suddenly it was done. So that is why you can notice I have not given the chapter 3 exercises also on YouTube. That is not available just because it is reduced from the syllabus. So just now you will prepare chapter 1 and 4 for your half yearly syllabus. Let us now come to the topic, that is how electrons are arranged. We have seen the different discoveries of these particles, and we will now focus on the arrangement of the electrons, how these are around the nucleus. Nucleus was discovered by Rutherford. Let us see what about the electrons. So according to the Niels Bohr was a scientist who gave this structure of the model of the structure of the atom. So according to the Niels Bohr model of structure of atom only, we will say that the electrons are revolving around the nucleus in the shells. Shells are the orbits only. They are fixed path, just like the planets are moving all around the sun. Orbits or shells are having the electrons around the nucleus. These shells or the orbits are given the name, that is K, L, M, N shells. So these are the different names. They are in the order. The innermost is called as the K shell. That is the first shell. It is closest to the nucleus. It is the innermost shell. Followed by the second shell is called the L, and so on. And outer, as we move outwards, we will give the new names to them: K, L, M, N, O, and so on. So likewise it continues. So the number of the shells which are present here will depend on the number of electrons. How many electrons are there in a particular atom, it will decide the number of the shells. So you can see in this diagram, in the center we have the nucleus, followed by the different number of the shell. The first shell, I will write there n equal to 1. The first shell is K, then followed by number 2, that is, and I will write the numbers better, 1, 2, 3, and 4. So from inside out we have to move. The innermost is called as the first, followed by the second, third, fourth, outwards. So this is how the different shells are there, and they are having a fixed number of the electrons. So what is the number of electron? For your clarity I will tell. The first shell will always have maximum 2 electrons, followed by 8 electrons, 2, 8, then again 8, and then it is 18. So that is, first of all, we'll come to the hydrogen atom. You can see in the center they have the nucleus. It is having 1 proton, and because the number of electron in hydrogen is 1, so only 1 hydrogen is shown in this diagram. Remaining part is just calculative part, you can see through. Next is carbon. Carbon is having atomic number 7. Z means atomic number. So whatever the atomic number, it is called the number of proton, also electron. It is always equal in the normal atom, so it will be same. Electron and proton are same. Based on that you can calculate neutrons, A minus Z. What is A here? A is the mass number. It is mass number. It is given here. You can see in the symbol itself, upper part of this, that is the superscript, is the mass number. Whatever number is written upside in the symbol, it is the mass number. So based on this only these different electrons are distributed. First shell will have 2 electrons, second will have 8 electrons. So likewise we have to distribute it. So one of these let us understand in details, others all will, you can relate with this. So here we have one example, full details we will see. First is in the center, you see, that is the nucleus having the protons. 17 protons are there, 18 neutrons are there. This part will be given in the question itself. You see here 35 is the mass number, so that is the value of A. You can see in the place of A, from here only we have taken this data. Second thing, Z. Again in the symbol you see 17 is written, that is the atomic number. Whatever the z value is there, it is called number of electron. And the same z only is called as the number of protons. So that is both same 17. From this calculation only we will do a minus z, 35 minus 17. It will give us the number of neutrons. So like this only we have calculated this. So 17 proton, 18 neutron we have written inside in the center. Followed by this K shell will have 2 electrons. Now first of all, before drawing this diagram, you write in separate, in a rough work you will write this. Then you are having 17 electrons in this particular atom. 17 electrons are there. Now we have to distribute this electron in 3 shells. So first we'll have 2 already gone. Out of 17, 2 are gone, 15 are remaining. So then second shell will have 8. I told you already, L shell can have 8 electrons. So now you do that addition, 2 plus 8 is 10. Out of 17, 10 are already over. How many is remaining? That is only 7 is remaining. So we'll write 7 for the next one. So like this, 2, 8, 7. This comes as the electronic configuration. What it is called? It is called as electronic configuration of a particular atom. This is for chlorine. So now you can see they have made 2 electrons, 1 and 2 in the K shell, followed by 8 electrons. You can count 1, 2, 3, 4, 5, 6, 7, 8. So like this 8 electrons are there in the L shell. Followed by this next one, you can see they have made 7 electrons in the next shell. Only 7 are there in the outermost, that is the M shell. So like this you have to draw the diagrams. Any of these diagrams, if it is you should be able to draw. This is how the structure of the different atoms are represented in the form of the electrons distribution. After the electron distribution topic, now next one that is coming is about the ions. Basically a particular atom is neutral. It is electrically neutral. Why is it so? Because the charge on the proton, that is positive charge, it is balanced by the charge of the electron. That means number of protons, P plus means proton, it is equal to what? Number of electron. E minus means electron. The number of proton and electron is always same. We have already we have seen in the previous topics, that is electron and number of proton both are same in all the electrons. In all the atoms we will find this only. But in the case of normal atom only, what will happen? The number of electron may increase or it may decrease. Means there will be some gain of electron or there may be a loss of electron. If there is gain of electron, means addition is taking place now, so number of electron may increase. Opposite means loss of electron, means it may decrease also. So if it is happening, if the atoms are losing or gaining the electron, then what will happen? Then there will be a change in the number of the proton and electron. So obviously in the case of losing of the electron, now one example we will see, that is sodium atom. It is having 11 proton, 11 electron. That is normal atom. Equal protons and electrons are there, 11 on both sides. You can see. Now it will lose one electron. Sodium atom loses one electron, and what will happen? From 11 number will come now to 10 because one electron is lost. But proton is not lost. Proton is same. You see the number 11 protons. Both are written same. Here also 11. Second also 11. But electron is reducing. 11 से 10 हो गया है. So that is more protons are there. 11 protons are there. That is positive charge. And less electrons are there. Negative charge. Positive charge is more now. Because positive charge is greater, we will say that sodium will have a positive charge because protons are more than the neutrons. That is why sodium atom converts into Na plus, that is called as anion. That is called as cation. Sorry, it is called as cation. Whenever a positive sign will come, you will always say that this ion is called as a cation. Second case now, on the other hand, if the atom is gaining the electron, then what will happen? The number of electron exceeds, it will be more than that of the proton. Example we will see like that of the chlorine. Chlorine normal atom, what is there? 17 electrons are there in a normal atom. But on gaining one electron, this 17 electron will change itself into 18 electron. So normally 17 proton and 17 electrons are there. But on gaining one electron, 17 electron change into 18 electrons. So now if we compare earlier, proton and electron were equal. That is in a atom. But this atom changes into ion when the number is not equal. That is, now electrons are more, and because the electrons are more, negative charge is more than the positive charge. It is called as anion. That means Cl has changed into, atom has changed into itself into Cl minus. Now we'll write minus sign there because negative charge is more. अगर positive charge आता है then positive sign, negative signs आता है then negative sign. So basically what we say, whenever there is loss of atom, there is positive charge, positive radical is forming called as cation. Positive ion बन जाता है. Next is gain of electron. Whenever it is there, negative ion is forming, that is called as anion. So that is two types of ions are forming, and both these ions can join together always. They are having a force of attraction. Here some visibility is not clear. Na plus and Cl minus, two types of ions are there. Na converted to into Na plus. Similarly, Cl converted into Cl minus. Now you focus on this charge only. Na is positive, Cl is negative. Plus and minus, that is two opposite charges are there, and there will be a force of attraction between both of them that will lead both of them to join together. They will come close to each other and they will join together, and they will make a compound that is called as NaCl. That is, a single compound will join by the force of attraction that forms between NaCl. So that is NaCl, sodium chloride is forming. So that is what is called as common salt also. You are putting in the food. So that is common salt made of NaCl, sodium and chlorine. So more details we will see in the next class. That is all about this structure of the atom. Now we'll move to the exercise part. For your reference, you can have these answers if you need. Although you have seen already in the exercise, in the live classes, all these have been given. I will just scroll down quickly. Wherever you need any of the answer for your reference, you can note it down. This work should be done in the copy. Already you have completed, most of you have done. So that is all. Here wherever diagram is to be drawn, I have written the diagram number. You can refer that and draw. In the book exercise, the answers only I have mentioned for the objective. Remaining are already given here. This table is about the calculative part. Other than these also can be asked in exam. Any of the element up to atomic number 20 we can ask. So that is all for this present video. We'll end up the